Assalamu alaikum warahmatullahi wabarakatuh. You are welcome to physics class today. I want to use this time to discuss position, distance, and displacement and the lesson objectives. By the end of this discussion, we are going to be able to briefly describe the concept of position, locate points of locate position of points using x and y coordinates, define distance and displacement, and then solve some simple calculations involving distances and displacement. Okay, going to the discussion fully. The position of a point in a space or on a plane can be determined by two factors, which are the distance and the direction from a given point of reference. The point of reference is obtained by two lines that are perpendicular. These two lines, the vertical line and the horizontal line, are meeting at a point known as the origin, and that is point O, the origin. Okay, and this with these points you can locate any position on the Cartesian plane. Alright, more about the plane. The line OX and OY are known as the axes. You have OX and OY. The horizontal line is OX, the vertical line is OY. They are called the axes. And the OX is X axis, while OY is known as Y axis. And we should note that the points to the right of O are positive values of X, while the points to the left of O are negative values of X. The points above O are positive values of Y, while the points below O are negative values of Y. We equally need to understand that both X and Y are known as the coordinates. You have X coordinates and Y coordinates, and they are all taking reference from the origin. The X coordinate is sometimes known as the abscissa, while the Y coordinate is known as the ordinate. Now we are entering into the business. The business is to locate points on the plane. So we have a plane here. The points have been located already. I just need to explain how the points were located. Now we want to use this coordinate of xy to locate 2, 3. You don't forget that when we are locating, the x coordinate is written before y coordinate. So this -2 is on x coordinate, while 3 is on y coordinate. So what this one means is that -2 means from the origin you go towards left by 2 steps, 1, 2. So when you get there, you take 3 steps to the positive coordinate of y. So 1, 2, 3. So you have -2, 3. Then if you want to locate 3, 2, go to the origin again. You want to locate 3. That means you take 3 steps towards x. 1, 2, 3. Then you take 2 steps towards y positive. 1, 2. Okay, we have the point located there. Then the third one is -1, -2. Go to the origin, and -1. Don't forget you are starting with x coordinate. You take 1 step to the left, 1, and you take 2 steps to the below the origin. That is 1, 2. This is -1, -2. And the last point to be located is 2, -3. So go to the origin again, locate 2 steps to the positive direction of x, 1, 2. Then you locate 3 points, take 3 steps to the negative direction of y. That is 1, 2, 3, and you have the point here. This is 2, -3. You can see that each of the points located consist of distances and directions. We took certain distance and we took a particular direction before the points could be located. Now we are dealing with both x and y axis. The axis taking the reference point from the origin O, which is this is the origin. Alright, moving on, I want you to locate this point using XY coordinates and send your reply to the uh, chat box down there. Now, moving on with the agenda, the second one is to be able to define distance and displacement. So we define distance as actual length between 2 points measured along a given path. That is simple definition of distance. And distance is a scalar quantity. Distance has only magnitude, it has no direction. So we have some examples like 40 meter, 39 meter, and so on. Then going to the displacement. Displacement can be defined as a distance traveled or covered in a specific direction. So this is a differential point between displacement and distance. In a distance, no given direction. In displacement, there is given direction. So that is why displacement is classified as vector quantity, while distance is classified as scalar quantity. Distance is scalar because it has no direction, it has only magnitude. Why displacement is a vector because it has both magnitude and displacement. So talking about some examples of displacement, we can say 20 meter eastwards is a distance. If I said 20 meter is a displacement, is a distance, excuse me, but 20 meter eastward is, now we have both magnitude and direction. The magnitude is 20 meter, direction is eastward, so is a complete vector quantity. Right, now let's look at some examples. If you look at let's take the statement, a toy walks from excuse me a toy walks 6 meters due east and makes a U-turn back to travel a further distance of 4 meters. So the demonstration is here. You can see this toy starting from O and going, start from 0, going 6 meters and then turn, come back. So what is the distance traveled and its displacement? In this case, to get the distance, you just add the distances, the total journey traveled, okay, the initial distance covered and the final distance covered are added together to give you your distance. Distance is calculated as 4 meter 6 meter covered in the first journey plus 4 meter covered in the second journey to give you 10 meter. That's distance. In this case, to calculate displacement, displacement is one journey minus the other journey. That's the first journey, which is 6 meter, minus second journey, which is 4 meter, and that will give you 2 meter due east of the starting point. Due east of starting point. You can answer that there's difference between these two values. This one is just 10 meter. The direction is not mentioned, but this one is saying 66 minus 4, giving you 2 meter due east of the starting point. So you can see that this value carries a magnitude and direction. That is why displacement is a vector quantity, while distance is a scalar quantity. So we have this, the distance is usually longer than displacement. Distance is usually longer than displacement. Okay, let's look at another example here. If you look at in this demonstration, the journey started from here and goes this way, and 10 kilometer, 10 kilometer, 15 kilometer, 10 kilometer, and 5 kilometer. So to get your distance here, you had all the part covered. So that was 10 plus 10 plus 10 plus 10 plus 15 plus 10 plus 5. That will give you 70 kilometer. But the displacement is just this side, this point to this point. The starting point and the ending point gives you the displacement. And displacement value, if checked, is just 14 kilometer. You can then see that the displacement is shorter than distance. Displacement is always shorter than distance, so we should know that. All right, another one here, you have this total displacement is given as first final position minus initial position. The initial position of this object is 0, the final position is 6, so 6 minus 0 gives the total displacement and is a vector quantity. You should always know that displacement is a vector quantity. That's magnitude and direction. All right, looking at the third example, and this is if you look at the first example and the second one, they follow the same pattern. If you look at this one, it's a bit different from the first two we have solved. Okay, if a girl walks 4 kilometers eastward and 5 kilometers northward, calculate one, the distance covered, two, the magnitude of our displacement. Okay, let's have a picture of this. Let's put it into diagram. You see, starting from, I told you that distance position is located from a reference point, and you need distance and direction to locate the position. Now you can see the body is starting from reference point and goes 4 kilometers. This is 4 kilometers eastward, and from then it went further 5 kilometers northward. Okay, you can see the journey, 4 kilometers, 5 kilometers. So the distance covered should be addition of all the parts covered. So that's going to be 4 kilometers plus 5 kilometers. That gives you the distance. 4 kilometers plus 5 kilometers gives you the distance. That is 9 kilometers, and direction is not mentioned. But talking about the displacement, this is the displacement. The shortest distance covered is the displacement, and that is going to be in this case you are going to use Pythagoras theorem, because this has formed a right angle triangle. So that's going to be the square root of, that is opposite square plus adjacent square, and square root of that result will give you the displacement. So using Pythagoras theorem, that will be square root of 4 square plus 5 square, and that's going to be square root of 16 plus 25, and that's going to be square root of 41, which is finally going to be 6.4 kilometers northeast. You can see it's a northeast direction. This is north, this is east. That's the northeast direction. Okay, you can now see that this one carries both magnitude and direction. That makes it a vector quantity. This carries magnitude only, no direction. That makes it a scalar quantity. All right, you have these to look into as your own exercise. If you understood the three examples that we have solved very well, you should be able to answer this question. You will be able to now we should be able to now define, locate position of points using xy coordinates. We should be able to define distance and displacement. Look at the difference between them. Looking at the difference between them, I forgot to talk about that. One is the distance is a scalar quantity. The vector, displacement is a vector quantity. That is one major difference between them. The distance has only magnitude, no direction, while vector has both magnitude and direction. And one similarity between them is that they both involve they both involve magnitude. They both involve magnitude. That is one similarity. And the second similarity is that they both have same units. Both have same units. So those I've given two differences and two similarities. You get it? You should note that. And then we should be able to do some calculations involving distances and displacement. Thanks for your audience. I want to plead that you subscribe to the YouTube channel using the red button down there. Thanks for listening. Assalamu alaikum warahmatullahi wabarakatuh.